Okay, hi everyone. So I'm still setting up some things here, getting into the atmosphere, and the point today is going to be to code something spooky, and I'm going to try to recreate what I remember about this Slender Man game because I haven't played it since, I don't know, 10 years ago or whenever it was made. And I remember being very scared of it, and that it had to do something to do with walking around some dark forest, and um, I think finding stuff or finding your way out of stuff or something. I don't really remember exactly how it went, but it was kind of spooky, and I thought that it would be fun to try to recreate it without libraries and also have this kind of uh, like kind of remembering about basic math that we need in these kind of projects and um, try to use it to recreate something similar in JavaScript. Yeah, okay. This doesn't look exactly like I imagined it will look like, but maybe. Hello, Vlad. Maybe I can get it to look like how I want it to look. A little bit more creative trimming. Yeah, something like that. Okay. Hmm. I don't know. Let's see. I plan to remove this shirt like through editing. And see how this will end up looking in the end. Yeah, let's see. So here, filters. Okay, so somehow floating head coding today. Uh, I guess this is somehow okay-ish. It gives kind of the idea that, okay, floating head. Maybe here in the back it should continue somehow. Yeah, okay. Maybe this is fine. What do you guys think? Is it the floating head coding today? I think it's the floating head coding today. Yeah, something like this. This looks much more like dripping, I guess. Okay, yeah. So, I really don't remember much about Slender Man, so I just have to say it. Yeah, very scary. I really haven't played it for ages, and when I played it, I'm really scared playing games like this. So, not ideal thing for me to be coding today, because I don't remember it that well. But I want to recreate this moving around some scene, and then I remember there were some trees there, and I want to somehow make them appear 3D as we are moving in some scene. And then this scary guy, I want to recreate him, and I want to somehow make him appear in spooky situations, spooky scenarios. So the application I'm gonna make is gonna go on GitHub. I'm quite sure it's not gonna be very polished by the end, but it's gonna be something that you can check out later on and modify if you want to make better. I'm gonna paste this link in the chat here. And at the moment it's nothing, so it's just an empty project, and I have it open here in my VS Code. Hello. So I have it in this VS Code here open, and I'm doing fine. How are you? For some reason, I can't zoom some of this thing. So, vibe puff, Sharma. I'm fine, yeah. Doing good. Trying to somehow focus on this new project now. So, I want to create this kind of Slender Man clone without knowing how Slender Man works anymore, because I haven't played it in a long time. So I think this adds like a little bit of surprise factor to it, because after implementing this, at some point I'm going to try to play the original and see if I got anywhere close to the feel. My body went away, which is funny because I'm eating now, and I'm eating these cherry tomatoes, and I wonder where they're going. Like, will they look like or not? I don't know. Yeah, body went away thanks to the miracle of OBS filters for the camera. Okay. So this is the application, opening the developer tools as well, because you just can't code without them. And I guess I will just begin with the basic stuff. And I'm going to start by making this kind of canvas application that spans the entire page, I think. So let's just make this font bigger because you can't see anything. Like so, and let's try stretching it to fill the screen. Okay, and I'm gonna add it some style as well. Let's do that in a separate file. Give it a black background color so that we can tell it's there. And it's there. Just that this margin here that appears around the body, I want to remove it, and I go here. And it's gone, but these scroll bars are still appearing. So this is somehow how I want this to be initialized. Yeah, blood dripping effect from under this red. I don't know. I mean, I actually have on my to-do list to code this thing in one future Halloween session, and maybe then it could look more animated. But now it's just this, and yeah, if you give me ideas, maybe maybe I'll use them in a future video. Why I don't use Emmet? I don't know. I got very used to coding everything because when I teach in class, I don't want code to magically appear, and then if students didn't see me doing the like, and okay, I don't even have it enabled in my VS Code, but basically, I don't want me to do something small and then a bunch of code appears, and then students are like, wait, what happened? What did you do? And then only couple solved thing, and I normally do teach some kind of lessons on how to use VS Code and what are the tricks. But I got very used to somehow typing the things myself, so I know exactly what it's added there and so on. So no good reason, maybe. It's just a use. I got used to it. Yeah, I did want to do this blood thing as a video, but maybe I will someday. Okay. So we have the canvas, empty canvas here at the moment. And I think I want the script to go somewhere else. So yeah, game.js. Ah. And let's say I want to define a new game on this canvas. Let's create some kind of class for it. I'm going to store these this canvas as an attribute, and I also get the reference to CTX here. And let's say that the game will have a draw method, and in it, let's just draw something basic. So maybe a circle in the middle. So like that. And something like that. Okay, I need CTX here. I'm gonna do this destructuring assignment from this so that I can use CTX here without this in front of it. And actually the canvas width and height can be retrieved from canvas as well, so I can also get a quick reference to it. Makes the lines shorter and no need to access properties of CTX when the canvas is already there, really. Okay, so I want to also draw, like maybe draw is not a good thing. Let's call it update, because it will also do modifications of the player's position and things like that. So update, and now if I refresh the page, I see nothing because okay, something. We have a start. Ah. So, movement, player movement, and this should be a player, right? So maybe we have that functionality in some kind of class. Let's say this, oh, wow. Sometimes I feel like this GitHub Copilot is reading my microphone and figuring out what I want to do. Yeah. So I have a feeling this code is going to be big. I mean, many files. So let's make a folder for JavaScript here. Move it there, this game.js, and update here the path so that it works properly. and the player.js is going to go in it. We create it like this, and really what I want to do here is take out these things, and the player should be added to center like this. And then here in the update, really what I want to do is tell the player to draw itself on this CTX. So now we have to modify this player. On the center point. Sure. And here I'm going to paste that code from previously. Okay. Size should be also here. Okay, so let's see if this works. Seems like everything still works because the new size is being updated here. Yeah, hello, Ratan and floating head, yes, present. Hello, Harry, Harry, how do you pronounce it? Floating head is just my attempt to have people that opened the video accidentally stay here for a little longer time. Honestly. Okay. So let's commit something here. So if somebody wants to follow along or, I don't know, work with the project at this stage. Then it should be appearing here now. And of course you can follow along these things later as well. Like the video will stay on the channel in the live section. Basically where all the other live things are. Mostly these advanced drawing app videos, but anyway, it will stay there. So on the channel, if you go to the live section here, is probably where you're gonna find it. It's not gonna be a regular video listed here. But okay, so we have the player there. We need to have some kind of way of moving the player. So controlling him, I guess we can say controls like this. And let's implement these as well in a separate file. So controls.js. And let's have it go left, right, up, down with the keys. So this reminds me of the code we had for the self-driving car series. I think it's kind of similar to that for some reason. Yeah, I think I'm just going to write the function here, avoid that kind of binding issue. So depending on the key, with the arrow keys, toggling left, right, up, and down. Now, before I just said that I want to avoid code automatically being generated, but now I accept these codes coming from Copilot. So basically, I'm not very sure why I do the things that I do. But I mean, normally I have Copilot disabled as well. I don't know why it's on now, but I think it will help me make a better project. So I guess I keep it on. So like teaching coding and coding for real when I'm not recording videos is very different. I think that's kind of like the main thing I'm trying to say. Yeah. And the reason why I'm implementing it in this way, kind of similar to the self-driving car, is because I don't want the player to just move a little bit when I'm holding up and down and left and right. I want it to actually have a little bit of momentum, like speed up and slow down, so that when you lift your hand off of the key, it doesn't immediately stop, but it has a little bit of um, inertia there. I think it feels nice. So in a sense, it's quite similar to what I've done there. Maybe I don't know. Mm. We'll need a way to do these updates, so move the player's location based on these controls. But at least now the controls hold if any of these keys are being pressed or not. So let's try that. Let's have an update method for the player. Let's log controls to see what we are getting there. I'm using table because maybe it looks nicer in the console. Let's see. And in the game, I want to have an animation loop. So yeah, this is quite good, but maybe we don't need this update just yet. We will use it. We will implement it later if we need to separate the drawing of the player and updating. Yeah. Let's go with this variant, calling this function like so. And updating the player. So when more updates are needed, I'm going to group them in an update method and then the drawing maybe in a separate. But at the moment, it's just the player there. So I like to refactor things when it's need to refactor the things. So now I'm getting here on the right the values of that left, right, up, and down. And if I'm going to press something, it doesn't. Oh. why it doesn't work. Hmm. So looks like that console table looks nice, but actually takes more power from the browser, and I think the application was stuck. But now I'm pressing the keys there, and it seems like the controls are being updated accordingly. Okay. Hello, Sebrunze. Yeah, live coding. And you caught this very special one with the floating head. Okay. What is Google's Hindi translation sound? Like if I type Hindi in the Google translator and I listen to it,
Hindi,
I actually don't hear anything because I'm listening to music at the same time.
Hindi,
Okay. But there might be two of them.
Hindi,
There are actually two of them. But anyway, I guess it's Hindi. Oh, somebody's in Hyvinkää. Where is Hyvinkää? Okay, it's there. Nice. I'm far away here, but tomorrow I'm going here, so maybe it's going to be like halfway. We getting closer. Ah, change language to Hindi. Yeah, why? Yeah, I don't know why I did that. So I, for some reason, wrote there Hindi.
Hurry,
And stop music, play
hurry,
Hari. Let's listen again.
hurry,
Hari. Okay. Okay, I guess now I did it correctly. Okay, so controls are there, but moving the player. So let's add for it a speed also. Defaulting to 0. And when we update these, let's take the controls in account. A speed. Let's actually consider a movement vector. So if I'm going to draw here our player position, and let's say that it's moving upwards like this when we press up. I want when we press right, not for it to move to the right. I want it to just modify its angle a little bit. So that we have a kind of direction vector that we move the character, and then it's going to move according to that speed in the direction of this one. So yeah. So direction, maybe it can hold an angle. Let's have it like this. And the direction will change with the left, right, up, and down. So Copilot wants me to destructure the elements there, and then, yeah, it actually changes the direction like this, and then speed increase, decrease, depending on that one, and then doing an update on X and Y using polar coordinates here. So this looks good. But there's no friction. I mean, it's never going to stop if we release up. So let's just see what we get here. Game update is not a function. Oh yeah. We don't need this anymore. Maybe we want to initialize it, like specifically initialize it, and that will call this. Or just start. I think that might be a better name. I don't know. Okay, so up and down are doing now this, and left, right, it kind of works, but it's a little bit hard to say what is this, the direction it's moving at, because it looks like a circle, so you can't really tell where it's facing. So by default, direction of 0 means we're gonna move it to the right. I guess it's okay, but I somehow prefer the direction to be towards the top by default. So I really don't know. Let's have it default towards the top there. So minus half pi. And now when I refresh this, if I press up and down, it moves it like this. Left is gonna move it like that. Let's make it also a little bit clear with how it looks like. So I'm going to draw just half an arc here. And I'm going to start at this top part so that it kind of makes a pointy arrow in that direction. So just a quick kind of minus radius. This is better because size should mean something else. Okay, and now I can kind of see the direction of the player there, but it doesn't rotate in a way that we want. So depending on the direction, it should change how this player looks like there. I think that we can do simple canvas tricks for that. Or play here with these angles and get it to work, but I don't have time for calculating everything like that. So I'm just going to save this, move to the center location, and then everything is going to be relative to the center location. So this becomes 0 because we're already, translate the canvas to that location. So then in that case, this, we replace it with 0. This, we replace it with 0, so it just becomes minus the radius. And this is 0 like this. And we should restore. This should give us exactly the same as before, but we have some error. Good. But the rotation is missing, so rotate to the direction. Actually, now we have to start it if the direction by default is going to be... I mean, the angles start at the right, that's the 0 angle. So we use 0 here. No, I want it to face upwards. So that would be like the starting point. And here I think we need to add this one to cancel it out. Yeah, so something like this. But of course, it doesn't stop when I stopped moving, and yeah, it's not ideal. I wanted to stop moving almost instantly. So really, it should stop moving as fast as possible. Yeah. Oh yeah, the drawing app. It's here and it's gotten updates, but I haven't made a video about those updates yet. So the drawing app are all of these live streams here, but starting with this one, I really started to work on it more offline, and other people have also been updating the code. I just made an update now, and it starts to become quite nice, I think. There are many new things added there, and I think Pieter had some recent update just this morning, and that was more about code refactoring and making the shortcuts work on Mac as well. And Yusuf is working on these text tools. Really nice updates with this one, with multi-line and moving the cursor up and down. It's now improved, and it even works with these different rotation angles. So yeah, new stuff is happening. And these icons are actually drawn using the app. So yeah, you can open any one of these projects to see how the icon was drawn. Like, I don't know, this text, it's just this, and it has this component and this component. So yeah, I like it. It's quite useful. And I've made a bunch of YouTube thumbnails using it recently. Let me see where they might be. I think these are the ones. So starting off with these kind of boring pictures here, this one was some thumbnail that I made live when implementing the green screen removal, the chroma feature there. But then these other ones for future videos, they are things that I also made with the application, basically by removing the green screen and then combining with screenshots from the applications. These, I don't know when these videos are coming, probably quite late. I'm quite sure that next year. But anyway, it's useful. I find it useful. And I will still make live streams about it, but at the moment it's quite tiring to somehow wrap my head around the project. It's also becoming really big, and it needs me to be like 100% in good shape, and it's rare to get me like that nowadays. But anyway, yeah, many many things changed here, and many more things will change. Okay, so this one, let's slow the person down. So this code automatically generated here is not really what I wanted. I want to be able to go forward and backward. And I really don't know if I want to rotate like this or not. I mean, this is more like, it's really very similar to that car behavior. And do I want him to just move left and right without rotating? I don't know. Then we need more keys to actually rotate, or maybe use the mouse instead. Like the mouse to look around. I don't know, really. Let's slow it down at least. So, let's have max speed. And now this friction. Now the speed increases and decreases. It can be also negative, this value. I want it to approach 0 from any direction. So something like this. Also, backwards, the speed should be limited by something. So maybe that. Let's see. No, it's slowing down too slow. It needs to slow down much faster. So maybe this, and then this should be maybe bigger, like so. And maybe this one actually bigger as well. So oh wow, too fast spinning around. Yeah, this was something else. I want the speed change to be even bigger. I think the friction can be even bigger. So that I'm basically going to max speed much quicker. Like when you start walking, you very quickly get to the maximum walking speed, right? Okay. And there's also that one annoying problem, like now, because of how floating point values work, this friction doesn't decrease it all the way to 0, so it might have a very small value, like this one, instead of considering it 0. And when small value like that is detected, really it should just put it to 0. So let's try to use friction. And we don't care if it's a negative small value or a positive small value, so I'm gonna use the absolute value here to handle both of them. And why is it moving? Ah, okay. Let's just use epsilon value here, the small value that we define. Because of how the physics works here, this friction here, it's quite big, so that it almost instantly slows the player back down to 0. And then and here we need to check this one as well. I think this is how I want it. We can play with it more later, but I like the way that this player is moving. But, okay. Should the player be allowed? Yeah, why not? I guess you can just turn in on the spot like this in any direction you want. Okay, but maybe the turning speed is a little bit too much, this direction change. Yeah, this is how I like it. Let's do a commit. Hey, Christoph. Yeah, now we need some kind of other elements filling the space as well. So at least trees to block the path, and then this Slender Man guy. I guess houses or other things can be also used, but I think that I will just stick to trees because there's something about going in the forest in a dark forest that is more spooky, maybe. So my thought process here is I want to get the top view and then make a kind of 3D view based on this kind of positions in this 2D mode, because we won't have anything like hills or really a change in the z-axis. So It's really a 2D game, but then we somehow extrude it in the third dimension and have a camera there somehow. Yeah, so let's fill the stage with trees. Hmm. I don't know how to do this. Do I want to bind, like have a bounds around the game area? Maybe. Yeah, let's say that we put here a fixed tree count for now. So when we generate the trees, we have a tree count and some bounds. This code that is generated here is quite nice, but I want to give more responsibility to this object. So center here, it's fine. It's calculating center at a random X and Y location, depending on these bounds. Like that. Size is something that the tree itself will decide. So new tree at this center location. And this is unnecessary. Also, this code is getting a little bit annoying. So I'm gonna create two files here. One for math and one for tree. I will implement this linear interpolation here. So like that. Basic function. I think that if anybody doesn't know what it is, you can find it on the channel somewhere. So I have these tutorials there. This one. But basically, I want to reduce the code that I have here inside of game, because what I want really is to generate the tree between bounds left and bounds right, really. And this formula here, it's very similar to the formula that we have here. A plus A is just at the end in that one, and T is in the front. T is that random value that we see there. So instead of writing it like this, we can write linear interpolation between bounds left and bounds right with the random t value. And the same thing goes for y. It's just easier to read, and we know exactly what to expect from this value here, from this code. And now the tree itself, I want to draw them. So let's just draw all the trees like so. And it doesn't exist yet. So I have to create also this. Center. Wow, it tries to draw something nice. Let's see what it might be. Yeah, but I think this should work if the code is not bad. Ah, okay. We don't see it because it's black. What did it do? And why is restore here? Oh, translating, but it's translate by itself. It's not really. I guess it's fine. But why? What does it look like? So, two strokes here. Let's use line. Oh, wow. Okay. It's fine. Yeah. So the center tree location is exactly in the middle of this crosshair here. Okay. You can't click on what? You're welcome for the visualizer. I hope it helped somehow. Okay, but the trees are too close to each other, and I don't like that. I think I'm going to just check if it's close to something else, and if it is, then I will not generate it there. So so I won't push the new tree at the center if there are trees already too close to this one. So if the distance from this center that we are calculating to any tree center is less than let's just say min distance, because I don't think we will need the min distance for anything else, at least not yet. So And let's actually pass it here like so. This function generates trees, but if we want to generate more things, we could actually reuse it. So I'm passing here the min distance as a parameter because we might want to reuse this in different locations. And like it could be generate spaced out things in side bounds, and then you take just the points from there and convert them to trees later on if we need it. I don't know. So I'm thinking maybe a little bit too much about engineering this thing. But anyway, yeah, now this is not needed here. So if nearby tree, if no nearby tree, then I just generate it like so. And now the count here, okay, I need the distance function between 2 points. So let's do it in math here. Mm-hmm. And I want to consider the player as well. Like now the tree is on top of the player. So when we find the tree, yeah, I don't like this code very much. So let's just say centers. I'm going to take them out like this. So I just take the center of the trees that exist. I'm going to push the player center into it. And now if centers find a location, a position, so that the distance from this new tree center to that location is less than distance, then nearby item. Okay. So now the tree shouldn't generate on top of the player, but this minimum distance, I think I wanted maybe a bigger, maybe 100, so that things are more spaced out. This is fine. And the code is not that great because the count, the number of trees that we are getting there is not really 100 anymore. So it's 44. And when I refresh, it's 40. And when I refresh 38 and refresh like 38 again, 36, 34, 35, 38, 41. So the number of trees depends on how lucky these tries are here. And I don't want to overthink this. I'm just going to generate some trees, aiming to get this value. To be a little bit more specific, I'm going to say tree max count. So I know that there won't be more than 100. But basically, this value can be even 10,000, and it's still going to look something like this. So I think there is no problem doing this. And now the character can move around like so. Yeah, good. Maybe too fast. Or maybe the trees are just too close to each other. So I'm going to say here area size 10,000 and minimum distance 500. I liked the minimum distance before, actually. So this is fine. It took a little bit longer time now to draw, to refresh the page, because it's trying to generate a bunch of trees in this region. Yeah, but I have to explain a little bit myself. So the reason I didn't slow down the player and decided to do this, let's put 200 here. Yeah, this is something that looks nice. And the area expands outside of the screen. The reason I didn't want to change the player so that it moves slower is because I already got the player move in a way that I wanted. So playing with that again now would have been not so great. And also because I wanted the space to be bigger so that there is more area to explore. And now in drawing the game, maybe I would like to center on the player. Or maybe I don't bother with that because that's going to be something for the 3D perspective to worry about. So just know that there is some game outside of the screens here. Some things are there. And I think it's time to move on to do the 3D perspective. And I don't really remember how to do it. Oh, okay. 5 a.m. Wow. I need morning coffee. Yeah. So, 3D perspective. How do I want to do this? Let's do a commit. Really, I mean, if you think about where we did this 3D perspective, it was inside of this self-driving car course in this very late lesson. So somewhere very far away here. These ones. Like if you look at this thumbnail, the camera was placed behind the car so you can actually see the car. But I remember in that Slender Man, you don't see your own character. You're basically the character. So the difference is going to be basically that this viewing area is going to be at the player itself. So if we have the player here, then looking forward, like in the same way that we have drawn the player inside of our canvas like this, whatever is inside of this area is going to be, should be rendered in the 3D screen. Everything else doesn't exist really. So that's kind of the difference here. And let's try to draw, like, get some points here, like on somewhere far away here and far away here, so that we can visualize this viewing area, this camera viewing region, also in the 2D mode. And then figure out how to do the 3D. And I think that I'm gonna have to watch my video to learn how to do that. Yeah, probably here. But anyway, let's start with the simple things. So camera. Like so. And I think that the camera is going to just be defined here. Yeah, and it's going to be defined on the center to follow the player. This is, I think, what we want, really. And then let's draw the camera view area, whatever we want to call it. So here we draw the player. Before that, I don't think it needs to update because, or yeah, it needs to update. It has a reference of the player, so the player, the player's locations are clear. It's just that, and they are updating, but the camera needs to process somehow to move according to that location and figure out the new, that kind of triangle there somehow. So maybe we have a method for doing that specifically defined like so. And now let's create this camera object. So yeah, those are good variable names. Offset, I don't want to have any offset or any speed. I want it to just be stuck on the player, like if the player has some kind of, those kind of head-mounted cameras or something like this. And draw and update. So the center always comes from the target center, but I want to also draw that kind of triangle there. So from here, I need a point here at some kind of distance away from here. Max view distance. Let's call it that. Something like that. And this is the center point, but we also want to get these, and we could call these maybe leftmost point and rightmost point or something like this from the player's perspective. So if everything here would be upside down, then left would be here and right would be here. So anyway, maybe it would be good. Let me move some of these things a little bit down here and like if I'm gonna add another point here, maybe F for front, then, oh, okay. I don't know what's happening there. Why is it? Okay, I think there might be some bug in this application. Yeah, I don't intend to do that. I want to draw a new line here, but it's somehow selecting things as well. I think some event listener might not be removed properly. Have to debug that. Anyway, so if you think about all of these points as on a circle, like on a very big circle, something like this, then F is just in front, and then L is on the left somewhere, and R is on the right. And maybe we can consider this as being, okay, something is definitely wrong here. I would like to debug this, but I can't do that now. How about if I save this file? And refresh. Maybe there is some temporary bug. Nope, it goes with the file. Okay, I really don't know why it's happening. It shouldn't have this issue. But maybe some of the recent updates coming here broke something. Anyway, I can draw it on a new layer. I think that's not going to break it. So on a new layer, this should be a 90-degree angle. Yeah, weird. Something is very strange here. Right. Yeah, we will need this z-axis. So, happy Halloween. Thanks for liking the content. We will need the z-axis. Diwali. Yeah, I kind of know what Diwali is, but not very much. It's some holiday in India, right? Yeah, okay. India mentioned there. So let's see. How do I draw that kind of... Oh, wow, I broke something. Yeah, that front point, F. Okay, FOV, field of view. This could be a good way to talk about things. But let's just have that point F. It's going to be somewhere in front of the center. So It depends on the direction. Let's call this front, because this copilot might actually help more if the variable name is clear to what it means. And sometimes these formulas come easier from it, that I can just look and see if they are correct or not. And now the drawing here, because if I try to implement these formulas, then I might do some silly mistake, and then it takes forever to figure out what mistake I did. And sometimes it's just something very silly, like maybe L here instead of I, and I just don't see it forever. Half an hour can pass for something stupid like that. So I really find these AI tools useful for that, but I always kind of check to see what is happening. No, I want this to also be relative to the center point. So we are getting this now. It's maybe too big, this size. Yeah, this is something that I can see the tip there. And if I'm moving, it also moves with the player. But let's have cyan color here so that it's clear that it's a different object. And let's draw the camera after the player, so that we can clearly tell that it starts in the center of the player, because that's kind of the intent here. So yeah. And now the other points, so the one on the left and the one on the right. I don't like this code. It's becoming hugely messy here, right? Thinking if I should implement vector operations. Let's do that. Let's do it in this math. So I'm constructing the vector here using xy values, so this Cartesian representation. But maybe I want to also have functions like to construct it from polar coordinates. So direction and magnitude or length, that's fine. And then I have here this formula that has been written there maybe a couple of times, but with these parameters, and I don't need to remember the formula every time I write it. I can just use this kind of meaningful conversion function from here. So two ways to construct it, but JavaScript doesn't support these multiple constructors, so I have to do it in this way. And then function to add vectors. This looks good. Let's have a static implementation of it as well. Maybe it can use the previous one. So, or let's not reuse the function because it's a little less efficient. And it's so easy to write that we are not making mistakes here. So with this implementation now, can we get our code to look better? Because camera. This is quite messy. I don't know. Let's see. This front offset. Yeah, we can do that. And then front becomes add to the center this front offset. So it's the same code as before, but the complex operations there were reduced to these function calls that are meaningful vector operations. And if I didn't make any mistake, everything is still as before. And now if I want this left offset, then I don't want to add half pi to the direction. I want to subtract half pi. Okay. Half pi, quarter pi. So if you think about this one, I'm just going to create a new layer to avoid that bug. But I mean, half pi is 90 degrees. I want it just 45 degrees. So pi divided by 4. Radians. So let's see. Let's have FOV angle, field of view angle, and then this left offset minus FOV angle divided by 2. So this is a little bit more clear, and we add it to the center as well. And let's try to draw this one too. So move to center again and draw left as well. And we get something to the left there, and it seems to work from all the orientations. And we can do the same thing for the right also. So like this. And I think we don't need to draw the center one anymore. I mean the front one anymore, because I just want that FOV to appear there. So to left and to right. But if we actually move to the left and then do a line to center and then a line to right, we get the same thing with one less operation. So this is fine. And then if we close the path, we get also that triangle appearing there. So something like this is what we want to do. I think so. But how do we do this now, the other view, basically? the 3D view. Let's look at this explainer from the self-driving car course video, because it's going to remind me how it works. I don't remember the math. Yeah, so let's see.
These pieces of paper
I
are
don't
those
hear it, so...
building bases. Now, these pieces of paper are those building bases. Now, here's what we see from this angle. Quite different, right? They're not rectangles anymore. What we'll need to do is figure out new coordinates for each point. I'll put this screen here for reference, and let's try to figure out the screen coordinates for this point. Let's call it P. Now, imagine a line here coming from the camera. We don't really need to imagine it, we had it already when we calculated that tip earlier. What we'll first do is project P on this line, like so. Let's call this new point P1. See this right triangle here? It intersects the screen, making another similar triangle here. Now, this screen can be anywhere. What changes is just the zoom, pretty much. So let's say it's 1 unit away, so really close. We do this because it makes the math easier. You see, when triangles are similar, this length divided by this length is the same as x divided by 1. 1 goes away, so we have our x. Now, to figure out why, we look at things from the side, like this. On computers, the vertical axis goes down like this, so our camera is at a negative z value. Now let's simplify a bit and focus on this triangle. There's another similar triangle here, but upside down. This is the y that we need. So y divided by 1 is equal to minus z divided by this length, and we have our y value. Now these x and y are on the screen that is 1 pixel away. We won't see much if we leave it like this. My diagram was not to scale previously. So we still need to multiply these using the size of the canvas we want. Let's go to the
Yeah. Let's see, any useful code here. So first of all, camera should have a Z as well. So let's just put 30 and see what that means. And then we need to project a point on a segment. So project a point on the segment. And the segment is going to be defined here from center to front, basically. So, so we will render on a context. And so segment, I'm just going to use arrays here. I don't have patience to implement objects like in that other course where I cared about this much more, like the code structure much more. And with the segment, project a point, project P on the segment. So we will have a, and then we get the P1. So we will get P1 as a project point P on the segment. And P, it's just gonna look at all the points. So when we render on the context points like this, and here yeah, so for all of them we do that. So the code here is a little bit different, but basically I want to get the same functionality without unnecessary software engineering. Like this project is so big, such a monster that we needed some kind of better structure. But this one is not that important. Oh. Oh, wow. Thanks. 3D factor. I'm happy that it helps. What kind of lessons do you teach? So then we get P1. And for P1, we have to calculate X and Y. So X is going to be distance from P to P1, same as there, divided by distance this center to P1, exactly like that. And then the Y value.
The canvas.
Divided by distance center to P1. Yes. Okay, so I'm mentioning here that actually this visualization, I couldn't show that you could have used P here instead of P1, and that's actually better. I think that, I don't remember if the visualization didn't let me explain it that way. Can use P instead, P1, and I think it's better. I don't remember why I didn't do it like that. I just wrote the message, but this should work. So when we render on the context, we get these new points here, these new locations on this other context. And with this X and Y,
that is going, let's have CY half the canvas scalar is return X scalar. And then let's see what.
So also scaling these, right? Because otherwise we're in that 1 by 1 space there. So yeah. And I just want to get the X scaled now. So I think like that. And this is going to be the point that I want drawn. So let's just no. I think scaled X is enough. Let's just see what we are getting there. And fill. So now we are able to render some points, but the distance function is there. Project point function is not there. Point on a segment. So let's see that one as well. I'm just going to add it here. And Let's try it. It looks like maybe it's correct, but I'm not sure. I have a video on this, and we can copy the function from there. But let's just see if this one is good. Because it might be, but it's trying to do everything in one row, and I don't like it. It also has here a scale function that is used, method, which we don't have. So it's for vectors. It's also assuming that the segment is coming with vector objects, which it might not. So yeah, let's try to add scale. And let's refresh. It's not called anywhere, that render method, so no bugs at the moment. But we have to call it on some other canvas to visualize it. So I'm just going to copy this as top canvas and camera canvas. So this becomes top canvas, top canvas, top canvas. And maybe the game needs both. So camera canvas. Yeah. And then the game. So let's rename this symbol to top canvas, camera canvas, and this one and this one, to be clear about it. Camera context. And when we animate and we draw these things, I also want this camera to render camera CTX trees, the tree centers. Yes, so this is good. Let's make it more clear like this. Okay, and now this other canvas doesn't fit anywhere, so I'm just gonna make this one use half the screen. And the same things for the camera canvas. And there it is. I don't see anything. I don't see anything. So I'm just going to search for the render function and start debugging by placing a breakpoint there. So like this. And I think now I can control this one like so. So I have a value for P. And oh, it's drawing them on the top side of the screen. I think so. Yeah, let's check this again. So I think Z needs to be up. Still nothing. This should be visible, like 41 and 3. Somewhere here, but I don't see anything. Camera canvas. Oh. It's here. And it's black. So, okay. I think these should go next to each other so that that space doesn't appear. And now it's here on the right. And let's go in the CSS and refer them as top canvas. And that one can have the black color background, but this one, camera canvas, let's make it gray. Okay, and now we get something weird there, but we are not clearing the canvas, and I think that the center point is the top left corner when we want it to be in the middle. Designers to code for interaction design course. Okay, nice. So our designer is able to do some more creative things when they code instead of using some like applications made for design purposes. So, I think it's time to separate these. Clearing both of them. Updating these things. Drawing the camera trees and player. And rendering. Update, draw, render. These are more clear now. And let's see if that problem went away. Yeah, so no problem with the forgetting to clear the canvas, but I need to move that thing. So when we project the point, so this code works. Projecting the point, I'm quite confident it works. If you want to know why it works and how it works, you can watch that other video on distance from point to segment. So this one projects the point on the segment, on the line support, really. and then it's basically projecting the point, and the segment is a part of this video, and then the distance to the segment is also an extra thing there. But this is a little bit different implementation, and I would have done it some different way, most likely, to make it more clear. But these AI tools implement it in a way that, I mean, this operation is so common that it's probably implemented in so many different packages that it found one and it used it and it's correct. And I'm not going to try to explain it, but you can find the explainer if you want in my video, or just Google it. There are a bunch of them. Yeah, I actually have to teach finite state machines on Monday. No, in couple of weeks maybe. I have this course ongoing on this discrete mathematics and computability and state machines. I mean, this finite automatons are part of that. I don't know. I mean, on YouTube, I tend to just do things that I find excited at the moment, but I don't really follow some kind of curriculum plan here. At work, everything is much more structured, but that tends to be more boring. Like you have to teach or you have to study a specific thing when the teacher tells you, not when you're in the mood for it. And I don't know. I've been thinking, because many people ask, should I make courses on design and structures of algorithms, or this kind of mathematics course. I think I'm quite happy with it at the moment. It's very applied. I don't know. But yeah, good idea. I'm really thinking about what should I publish in the future, because at work I'm starting to have even more responsibilities, and I might have to reduce the videos. I don't know. I also have some idea of this massive course that teaches some mathematics in an applied way. I plan to make it as a kind of challenge for people. And in that one, I found a really nice way to teach about gradient descent, because I don't like to teach it in the neural network context. It's pissing me off. I've been trying for so long to find a way to teach it in the self-driving car course, but the neural networks, the dimensions increase so much in that one that having a small 2D, 3D example is kind of pointless. And everybody teaches this gradient descent in a very abstract way, where they show a 2D function and they say you go towards the minimum. And I just don't want to do that, because I like to teach a very concrete situation where it actually does happen like that, not like a sketch of what might be happening, but we can't visualize because of the higher dimensions. And I found a way, and I'm really happy about it. But this course that I'm planning, it's going to be huge amount of work, and I think after summer I might have it done. But it's going to teach math concepts in a very nice way. Yeah, okay, sure. So in game applications, they tend to be a little bit more a little bit different. The way I teach them in this math course is I link them to to regular expressions. Now this is just at work, and I don't have any plans of making YouTube videos with them, but maybe someday. So I link them to regular expressions because I mean, fundamentally that's what they are. And if I just do the theory, it's very abstract mathematics, and students just get bored of it. So, and I get bored of teaching it like that. So I want some kind of concrete application. Yeah, it's really hard. But I found one application where I could teach these optimization, this gradient descent in a really nice way. And the space there is 2 and 3D. So this course that I'm planning, it's probably gonna do very bad on YouTube. Like, it's really not something super flashy. Maybe, I don't know. But I really liked it because I can extract from this one project so many nice things that I can teach, and they are general tools that you can apply in other things as well. And I can also make it as a challenge. Like people could try solving this puzzle that is gonna come, and discover some hidden mystery, and then I will release the course after people have some time to play with this. So then they get my version of the explainer, which will be very deep, like showing very many different things, even if you could probably solve it with simpler techniques. But it's just a nice way to present practically algorithms that I'm so excited about it. But it's nothing flashy like buzzwords that keep popping up nowadays when you Google computer science and algorithms. Yeah. So, project point, fine. And then game render, camera render. So here I think that I want to also... Was this considering the... Oh, okay. Okay, yeah, I missed a part. So it took there the scalar as the minimum, probably because I wanted something to fit on screen, so better than the maximum, because it's not a square screen. And then here it's cx plus x times the scalar, and cy plus y times the scalar. Okay, I think this is going to make it centered, like so. Okay, but we are missing something still. Everything seems to be on the right side of the screen, which is not correct. So when am I fixing that?
What we did, save offset on
yeah,
X,
same thing happens there
on the left
as well.
on the going perfecting it, and then
okay,
what we
I
do
need the
here
cross
is
product.
multiply by the negative value. Then that's going to, and inside we should be.
Yeah, and then subtract P1 from center and subtract P from center. So okay, and then here sine of C multiplied by that. So I hope this is going to work. I need to also implement this cross product here as a static function I need it for now. And it looks good. Doesn't work. Subtract is not a function. This was a normal method. Oh, no, it's, let's just make it. Let's just make it the normal method because it's shorter to write. And this doesn't need this P, it's just P. They are not vectors. Let's undo. It's easier to write like this. So give it also a static. So normally you want to have everything using the vector object now, but oh, this P is P. Okay. And now I think the problem is we are just trying to project all the points, but I just want those inside of this triangle. Okay. Well, this dev video, what I'm thinking about with the math is gonna be very, well, I guess I can spoil something about it. I want to teach how to make an indoor positioning system without any special equipment. And all the math involved with that, like the trilateration that you need to implement in practice, you need to solve it out. And figuring out the location, estimating the location based on the distance to the beacons, that's something you can do with gradient descent. And you don't have to use gradient descent for it, but you can. It's actually less efficient than something else, but it provides me a way to really visualize how your location is getting closer and closer to the true location by just going down the slope in the 2D world or 3D world. And I just find it so nice that I can teach it like that, and people can make this kind of whole setup at home without any kind of special things. All you need is a camera, like a phone camera, if you want to implement the positioning system on your phone. And yeah, you'll see. But basically, it's a very niche topic. It only works if you point your camera at those beacons. So it's kind of annoying in practice. It's not really very useful unless maybe you have some kind of 360 camera that sees everything at the same time. But basically, it's just a platform that gives me this opportunity to teach a bunch of different things in a very clear way. I hope that kind of gives some idea of the future plan. But that will be a course that will take me a long time to make. And I think I plan to make it as a really, really long video, like one standalone video. So it might decrease very much the amount of content that I want to do. if I focus on that one. But anyway, not coming until after summer, so let's see. Yeah. Uh, watching Radu. Yeah. Yeah, sure. Fractals. Maybe. I don't know. I mean, typically indoor positioning is done with Bluetooth or some kind of things like that. But why I don't like this is because you don't see anything. Like these kind of signals that are passing through the air, they're invisible. Like if you go outside and you want to explain how GPS positioning works, you don't see the satellites. They're just so far away. You don't see anything. You just assume things are there and everything is working. And I really want to teach positioning in a way that everything is clear. And turns out there is a very interesting way you can do it without special devices. And everyone can kind of follow along if they want. So the reason I don't want to use devices is because I don't want to. The other reason, like apart from this type of signal that it's invisible, but the other reason is that I don't want people to have to buy stuff to follow stuff along. So I'm sure most people have a camera or a phone or something, and if they want to implement the thing with their own stuff, like I might also share some videos of how I set up the room and things like that. But anyway, I don't talk more about that. This is taking too much of my memory and brain power, and I won't be able to finish everything I want to finish here. So, characters moving. All the trees are shown. I just want to see those trees inside of this triangle, really. So camera update should ideally return to me this triangle. Return this left, this center, this right, like so. And then inside of the game, when we update here, we could return what the camera updates as the FOV. So FOV is equal to this. And when we render, we can pass the FOV here. And when we select the trees, we don't just get their centers. We also filter those in view. Centers filter, center if the point is in the triangle. So point in triangle, center inside of FOV. Let's just reduce here the variable names a little bit because it's kind of clear that T stands for tree and C stands for center in this case. And now instead of passing all of them, I'm going to pass here just those in view, like this. But I need this point in triangle function implemented somewhere. So point in triangle, the triangle is an array with 3 points. I'm just going to hope this is correct because I don't have, maybe I still have about 2 hours time and also if energy left, and I just hope this is going to work. but looks promising. Oops. Let's see. So now nothing is there, but no, doesn't work. Or did it work? Maybe it works, but it's just so close that it doesn't show the point well. Let's make this triangle bigger. So in the camera, this max view distance, let's make it 1000. I don't get what I'm seeing there. So this might not be good. But let's look also here one more time what we are doing. So left, center, right. Update. Let's try the opposite. Okay, let's zoom out a bit like this. And when generating the game, I think we need a smaller area, 1000, like this. And let's put more trees like this. Even more. So why am I seeing that thing there? Kind of looks like a deformed triangle, like a triangle with rounded corners here. I have a feeling that the code we wrote for the camera is not correct, so let's double check with the video. Yeah, it should work. Let's generate even a smaller area. This point in triangle, I think it doesn't work. Yeah. Yeah. Yeah, it gets a while to get comfortable with it. And now I also think that I don't understand what is going on here, but there is this pressure about finishing something in time for the stream. And oh, let's see if we can find online some implementation. I don't want to install anything. I want to just see the algorithm somewhere. Okay, so this seems to be something that works. It's not JavaScript, but it doesn't matter. Yeah, if this goes, there is some technique of checking it by looking counterclockwise somehow and using sign for like negative means counterclockwise, positive means clockwise. I know how to implement it maybe, but it would take me forever to make it without mistakes, and I can't really talk while doing it. It's this kind of very annoying thing. Um, let's see if now it works. Now it works, but it's opposite. Okay, I'm gonna put where we got the algorithm from here. So so no, something is still off. Kind of, it works like I see now a corner there, and now maybe the other corner. Like this looks very good. But if I'm here, it's not at all what I expect. And if I'm here, I am quite sure that the point in triangle now works because of how it really is like so. Like the few points that you see here are entering the screen there, but the coordinates that we calculate for them are wrong. And I kind of suspect that the project point is wrong. So how about I take it from the self-driving car repository. It's actually not here, it's in the Understanding AI repository because this thing with the camera, it came very late. And I don't know if we needed this this project point before that. And I don't even know where it is since I used this one so long ago. Maybe it's part of the camera object. Yeah, okay, so it's here. No, it's in the segment. The segment project point is what I'm interested in. So I have to open this one. Yeah, it was a method of the segment. So let's try to write it like this. So P1 and P2 come like so from the segment, and then a vector subtract here. Oh boy, normalize is needed, dot product is needed. Add P1 scale normalized with the scalar. Many things I don't want to think about. Okay, magnitude scale normalized dot. And then we return proj.point. We don't need this information anymore. Okay, so still have to add some things there. Dot product, normalize vector, you get the magnitude and you divide it by that. We need the magnitude, it's just this length of the hypotenuse in the triangle where the point is of the vector is 1 point and the 0, 0 is the other. So then these differences here, 0 basically, this one. So maybe now it works, hopefully. No, now we have error. Scale is not a function. I thought we implemented it before, but maybe we did it as... Can we use this one or... let's try to use that one. So scale is here. No, let's implement a static version as well. So hey, it works. Yay. Haha. Okay, from all angles. So, what did I learn? Don't trust AI stuff too much. I don't know why it did a mistake with such basic things, but the project point and also the... What was the other thing? The inside of the triangle, both didn't work. Yeah, it doesn't always work, but it tends to autocomplete things quite fine. If you have code already, it tends to do things in your style and figure out the next stuff really well. I can say that I wouldn't have progressed so far with it in this live stream without it. But this took some time to figure out the issues. So yeah. And 3JS, sure, you can, but I want to somehow show the fundamentals of these things and not just do something really quickly. I think 3JS is based on top of OpenGL, so I would start with that maybe with this WebGL starting point basically. Okay. Yeah. So we have this. Let me make the game size as it was before. And move the camera a bit more up, maybe. Yeah, move the camera a bit more up. Maybe 150. Yeah. Okay, and I'm gonna do a commit with this one. So like so, and start styling things so it actually looks more like in an end product. So here the tree is drawn in that kind of this kind of plus here, but I want to draw it, I want to render it here to look kind of like a tree. So how would that be? When we are inside of this camera code and we render the trees, we just project the points, get the new points, really, and then draw a circle at the bottom there. This is fine, but let's have a helper function here, render point. Or project point. And here I'm going to take, I don't know what it's doing there, but I want to take P and the segment like this. And return scaled X and scaled Y. And here, project point like that. So CTX not defined. So yeah, okay, the CTX is needed for the canvas size. Really just the width and height of the canvas are needed for this manipulation here. So when we project the point, I'm going to pass here CTX canvas, and then that one will be destructured like that. And here projection X, projection Y, and we get the same thing as before. And we also can do this by getting projections. Points map, and we do that. And the reason why this is nice is because it now separates drawing of these things for later. So it keeps the drawing of these things later. We have the same thing here. And now when we draw them, we can draw them however we want. So so let's just render tree here. Or have the tree class do it. Tree render on this CTX with this projection, and so to separate it from the I don't need this. To distinguish it from the draw, which is this crosshair from here. So now we get these points like that. And I can make it look like a tree. So I think that what we will do is we draw a triangle. Or let's just first draw a vertical line, CTX, move 2, 0, 0, line 2, let's say 100, and stroke here. So now they are like that. And I'm just going to do some trickery because I don't want to do that kind of very complicated implementation from the self-driving car. So the tree height, it's going to be a fixed value. Let's say 200 pixels. And now when we draw it, when we render it, we also would like to get the distance from the camera to that tree and scale this height somehow appropriately. So no, this doesn't work because so something like that. And the scaled height is going to go here. And this distance to tree comes from here. We need the point, the original point as well. And we need them to be like we need the indexes to match. Yeah, this should work. And then here, that. And it doesn't work. it works. Ah, let's try to make this height bigger. Yeah, I think this height is gonna be scaled. Yeah, there's no normalization going on, so I need to somehow play around with these values like this. I think the position to... Oh, and it should be negative. Negative scaled height because the Z goes like that. So now it looks kind of like going inside of a deep forest. Kind of. But the tree should look more like a tree. So let's do here after this line. We go at the top. We are already at the top, but maybe we don't want this vertical line. Let's see. And then at the top there, line 2. Everything should be scaled here. It's kind of annoying. Yeah. Other way here. And this really needs to be scaled like that as well, and probably it's going to need a huge value there. Yeah, and I think that we also have to fill here. And there are these problems that some things, this should be in front. So we should sort these so that the closest ones are first. Very many things. I forgot how difficult these things are. Now it looks okay. And let's continue drawing this tree. So this is now the top triangle. Let's begin path and let's stroke here. These values should go here at the top. Okay, and the stroke. Maybe we want to stroke, or maybe we don't want to stroke those ones. Yeah, let's just leave it like that. and the other triangles. So it's going to be similar to this, but now I need to update this value, this scaled height, to move down. Or okay. Like this maybe. And maybe I don't need to move it down. Maybe I just need to reduce it. No. This is good, but I want to write it in the other direction. So first drawing this one and then the other one. So that means that the height here should start with the scaled height times 0.9 or something like this. And the width at the bottom maybe like this, but bigger radius, like so. And then the width actually decreases, so maybe 0.8, like what it was before at some point, and the height decreases as well. Something like that, but too wide. So something like this, maybe. The height, I think, could also Okay. Maybe the reduction here could be more significant. Something like this. So now the whole point of this experiment was to somehow figure out how to change this width and height on each iteration and repeat this code. So we can loop this, let's say 5 times. And if we do that, we will get something like this. Mm. Yeah, not good. I don't like that all of these lines actually go to the top there. So this move to 0 is something should be changed somehow. Let's see what happens if we use width here. No, I mean this one here. Maybe this way. Something like this. I guess it's okay. It should be lower. I'm too tall. It's like a giant. And yeah, other than that, I think it's fine. The color of this tree is kind of light if it's nighttime, so maybe this is better. And also, let's make the stroke style also dark green like this. I think it looks nicer. Okay. This was very hard for me to WASD, or what is WASM? The static. So if you think about this tree object that we have here, if you type tree height, you can get access to it. So it's an attribute of the class itself, not of the objects. For example, the game trees, and if you take the first one, it doesn't have height. It's undefined. But the tree class itself has a height like that. So when we have this render function here, I add it like this because I'm rendering not really a tree object here. All of these are just points, projections. I just have the center point really. But I use the render function of the tree class because I want it to be responsibility of the tree class. Normally you would do a normal method in this case because it would be nicer, or maybe, I don't know. But in this case, it's just a quick workaround to make the code still be part of the tree object itself, but work with normal points, not tree objects. So it's like that. But if you look in the math file, here there are differences. So clear things like scaling a vector. Like if you have a vector v, you could write scale like this in code with this method, or then you could use vector scale v with s like this. So two ways to do the same thing. And sometimes one is better than the other. Here there are some annoying things because I'm returning vectors here, but sometimes the things we pass to them are regular points. It's a mess. The self-driving car course has a better code structure here. Okay, but let's try one thing. I remember that part in this camera render project point. Here it was said that P can be used instead of P1. Let's see if it makes any difference. I think it's better. Without this change, it kind of gives a roundish effect, like the viewport kind of looks skewed like this, like a fisheye effect when you play with it. And P is better in this case. It looks more as expected. And I want the trees to fade in the distance. So how do I do that? And I want the canvas to be dark. Yeah, and the more we go in the back, the more dark we want it to be. So I'm just going to go to the tree, and when rendering it here, these colors for the stroke and for the fill style, I want to control how bright they are. So I'm going to say, let's fix the hue like this. And then here, let's try something like this. And this one, we can use this representation. And now the trees in the back look like getting darker. But the lightness should really be capped in some way, because very close to us it becomes white like this. So the maximum should really be should be darker, maybe -50 here. No. I'm not finding good values here. Cameras, max view distance. I want this to be something I can access from away, so max view distance. So I will rewrite these with the max view distance instead. And now here, the distance to the tree will relate to that one. So max view distance divided by the distance to the tree gives us between 0 and 1. If we scale it to 50, what? How can this be so big values there? If the tree is in view, then the max view distance oh, silly. It should be the other way around. And reversed. And reversed, and I don't want the nearby trees to be so bright. Yeah, something like this. So 1 minus this, everything multiplied by 20. And now it's fine. I also want the difference between the stroke. Somehow I liked the stroke of the, or let's not show the stroke anymore. I think that this kind of simplified view is better. The trees on the side, they disappear. I don't really like this. They disappear as soon as the player so you see here this tree is visible because this is inside, but as soon as this goes outside, this tree disappears. Maybe we can increase this triangle angled there a little bit. Let's see what happens. So instead of 0.5, maybe 0.6. Still disappears. Let's try to have it bigger. When it's big like this, when it's too big like this, then this side of the triangle becomes too close. It's not good. Okay. Hmm. Let's try to make this yeah, I think maybe we want to use the maximum value here. This is fine. I don't like that the tree is disappearing here on the right, but I think that we might compute a lightness value that also decreases on the sides. So lightness 2, it's a very bad name, but this would be from this center location depending on the CTX canvas width. So yeah, but I need to take the absolute value because it's in both sides. And let's try something like this. So lightness 1, lightness 2, and then no, I don't want to average. I want to I think I want the minimum. No. And this one, I think I also want it in reverse. I mean, inverse. And let's just use lightness is lightness 2 because I want to debug if this one works and it doesn't, or it does. So brighter in the middle and darker on the side, but actually this should be also scale down like this, and maybe this also divided by 2 here, or actually multiplied by 2, because I think that multiplication happens first. So this view here looks more like if a flashlight is on. And it also makes this tree almost invisible by the right. So it removes that kind of unwanted effect. In the self-driving car course, I explained like a better way to handle this. But now the problem is the trees don't fade, like this one in the back. When it goes in the back, it still stays bright until it snaps away. So that's why I want here to use, I think, the minimum of these two. And now this one, you can see it gets dark like that, but also as the things move to the side, they get dark. So yeah, but the camera, I think it's still too high up, maybe -50. This is fine. Okay. Whew. Maybe it's fine, I don't know. I would kind of like to see also the ground a little bit different color, but let's try this as well. So I'm first going to do a commit and say that, and check the chat. Green screen, yeah, very pro. Very good. Oh, WebAssembly, yeah, sure. Yeah, I mean, it should be more faster than JavaScript. I don't have experience with it, so can't say for sure how much faster. But for the things that we are doing now, I don't think that we have performance issues with these. So if it starts to have performance issues, then definitely you can use that one. The format of the viewing angle is not a triangle. Well, you could make it an arc, I guess. You could easily calculate the intersection between the arc and the circle, like you can just consider a very, very long triangle, like a very, very big triangle, something like this. And then the method for checking if the tree is inside the triangle, you could combine it with this one that checks if it's inside the circle, and that's just a distance less than some threshold. So then you could have this exact region. And that would be probably better, because now our triangle actually cuts the tree a little bit early on. It should be still visible in this range, but I don't care. I mean, for what I'm doing here, people won't really complain about this thing. At least I don't think so. So what happens is when I zoom out enough, this tree in the back is going to disappear a little bit abruptly, but it's already quite dark. And if this tree is close to the side, it's going to disappear smoother, just barely smoother, because of how that triangle is squishing a little bit that max distance. So yeah, it's a good idea and it would improve somewhat, but I don't want to do more than I have to. So it's time for Slender Man. And actually, maybe I said in some post, and I think it's something that Daniel pointed out. Let me see. No, Daniel, Danny. Danny and I had some kind of conversation. He would have gotten some free channel membership for answering some question in some video. And he said that he doesn't need it and that I should gift it to somebody else. And then I decided to do this kind of membership giveaway. So I'm gonna try to do it now. I don't know if it works, but I saw that if I open the live stream myself here, like this, wow, this is now Inception all over again. But basically, at the bottom of the chat, I get this option. And then there is this membership gifting. So from everybody watching now, if I understood correctly, there will be, if I press this gift 5 now button, randomly choosing people to get this channel membership for free. And I'm gonna try it. I don't know if it works, but something is running there. And okay, some people got their got some kind of membership there. Okay, good to know that this system works. I can gift sometimes, maybe. Back to coding. So this guy, I have to draw this guy and add him somewhere on the stage, like somewhere hidden, hopefully. That when you get to see him, it's game over or whatever. It's very scary. I think to kind of avoid work, yeah, this generate trees, I don't like it. So generate items. Items, locations, and then here locations push center, and we return these locations, and where we call this generate items locations, these trees we remap the locations like that, and not all of them. I think one of these locations will be this Slender Man. So take out one location like this. The trees will generate like that. and then new Slender Man at the Slender Man location. So I need another class file here. And I'm going to start it as a tree. Like I copy tree inside of this Slender Man because probably it's going to be similar. Slender Man, constructor, center, size. Size is really just needed for that top view. And I think that I will draw him as a text. Let's put S. Like that. I want it to align in the center, and the font size, I guess we can control it with this size. So size pixels, we don't need this radius here. And then rendering it, let's just use a different hue at the moment. So refresh. Oh, trees is not defined. Mm-hmm. Ooh. We don't need this, so okay. And let's go back to the main place here and put true so that we see both of those things again. I'm gonna zoom out as much as I can, and I don't see any Slender Man. Is it even working? Is the region too big? Let's use again another smaller area. Oh, we are not drawing it. Yeah. So the game doesn't draw it. When we draw player, camera, trees. Let's do the trees first because it kind of makes more sense. Player, camera like that, but here Slender Man has to be drawn on the top context, and trees are complicated. Ugh. Complicated because here camera doesn't know if Slender Man is in view or not. Slender Man in view, this is good. So this might be empty. And render Slender Man. It's gonna come as an array. I don't want that. So no. Point in triangle is gonna be just true or false. Slender Man is just going to be Slender Man in view. This Slender Man otherwise null. So if it's there, it's going to render it. If not, it's not going to render it. Like so. And projections. I really want to combine. Or just do it separately. So if Slender Man, we project like that. Yeah. And then I also want the distance to Slender Man's location and then to render it like so. Okay, so now, okay, big S is there. You can see it there. Problem is, treating it separately means it's gonna be drawn on top of the trees, even if it should be behind some trees. So the sorting happens here. I hate it so much. Yeah. Why I don't code in Python to get better reach? I mean, I like to visualize many things and I like to share things really easy. And basically, you don't need to install anything to work with JavaScript. So that's why I have JavaScript. It's probably the main reason. Because you already have a browser and you can try apps like that. And Python is not that great at visualizing things and animating things and stuff that I like to do. It has some libraries to do it, but they tend to be really slow. At least when I implemented the self-driving car application in Python, it didn't work as performant as in JavaScript. Web development has been made somehow for visualization. Of course, WebAssembly and those other things, if you really want to have very performant things, go for that. But you don't need to install anything. And to get a better reach, you mean like more viewers or something? I don't want more viewers. I think it's already kind of time consuming to reply to comments from those I already have. So it's fine if it stays like this. Okay, hello, the droid. And okay. Maybe I will make some machine learning things in the future. I do have a plan to do a clustering course because it was supposed to be done a long time ago, but I didn't. And it would be like phase 3 of the machine learning course. Okay. And so Pankaj and Timothy, you're welcome. Now back here to these things. I want Slender Man to be part of these points, really. So point, we store the point, we store the distance, and we store the type also. Tree in this case. We do that for these items. And then if there is a Slender Man, we push like so. So now items contains both of them, and we can sort them not by calling the distance method anymore. We just say like that by this distance attribute that we calculated here. Let's call it dist just to avoid confusion. And then projections p dot point. We have to use that one to get the projection that we want. Oh, I hate it so much. Let's have this again. Point, so the projected point comes like this. When I say I hate it, I mean that I'm running out of time. And so I need to preserve the type here in the projection so that I know how to draw it. It should also be items, really. Okay, and now going through the items, we can actually go through the projections directly now because the distance is already there. We don't need this anymore. Or let's actually keep the distance there as well, but it's coming now from this projection object. I don't want to change both of those other functions anymore. So if this is correct now, it should work. But for some reason, it just shows Slender Man there. Yeah, this was the problem. Okay. And the sorting is in the wrong direction. Yeah, now it seems to work. So this Slender Man goes behind in the right place there. Okay, let's work on how it looks like. So on this map here, it's just this S, this blue tree here. Maybe we make it red. It's more threatening. Yeah, and let's make it red also for the top view, this S there. Okay, and one quick commit now. I just say placeholder because it doesn't look like Slender Man yet, and the last commit is going to be styling it to look like Slender Man, and then I have to go. So one more thing, one more task, and then it's done. So yeah. Hungry. Floating head is eating a banana. What languages I know as well as JavaScript? I really don't know. Hmm. I think the best language I ever known is Java. And that's why my JavaScript sometimes looks like Java. And I also miss some functionalities from it. I think at work I use a mix of JavaScript and Python nowadays because I don't code anymore. I just teach. So those are typically the two things I use. So JavaScript for full stack development and Python for machine learning stuff. It's not easy to type being only a head, but these hands are floating, like this one is giving me a cookie. So that makes it easier. Looks like my blood is floating a little bit. Hmm. I don't know. I don't know. Study AI related things. I mean, how else can you be an AI engineer? I guess the question was for Captain 41, but I just want to be a floating head. I'm thinking, can I somehow use scale here instead? To avoid all these issues. Oh, Maybe. Damn, wish I would have done that for the tree as well. Let's see. Does it move up? So yeah, looks good to me. So Slender Man guy, his head is going to be like that, maybe taller. And I think that the head kind of looks like an ellipse, so I'm gonna use that one. Like that. Yeah, that's pretty good. And now the body. Rounded rectangle. I guess 2 lines for legs. Okay. I still need to do that thing with the hue. So I just copied this. Should have been that. Hue doesn't matter what we add, because this one doesn't have any saturation. So it's gonna be gray. And then we have the lightness value, which we also have to somehow do something with it. But the second stroke style, like that. So his body is becoming all darker as it's going away. And the head should be significantly brighter. So I think last thing I'm doing now is the head. Here. I want a scaler here. I think. Because the head should also get darker as it goes away and fade to 0 eventually. So maybe this looks good, I think. Maybe the original brightness could be a little bit bigger here. Okay, this is fine. I kind of want to do the final thing like a triangle here and then this tie shape. So how I would do that? I think when drawing this ellipse for the head, so these are the angle parts, 0 and 2 pi. If I do 0 to pi, oops. Then I get this bottom part of the head. But if I do this. And then this one. You see it has this shape now, but I want to connect somewhere here, somewhere lower. So plus minus. No. Oh, wait, that's the center point. So the radius here, it's 3 vertically, so 1.3, 1.5. I need bigger. I need maybe 3. Okay, kind of looks like a collar already. Let's see bigger how it looks like. Yeah, I don't want to do this more, so I think this already looks kind of nice. Okay, so disabling that thing, and I think we're done. Of course, this doesn't have sounds or it doesn't say game over when it's game over, but oh, I found it. Yeah, I'm happy with this. So it's just doing a kind of Where's Waldo thing, where you have to find where Slender Man is, and maybe I can do a quick game over when we do find him. So what's the distance now? 200, about 200. So but I also want to know if Slender Man is in view. So let's say here actually. So Okay, so it ends. I can't control it anymore, and it turns everything to this kind of reddish view. That's it. I'm done. How did it go? Was it nice? Interesting? Oh wow, politics conversation started. I don't think I had any video about NLP, about string tokenization. Okay. Keyboard, nothing special. Let's see the floating keyboard. It's just basic stuff we have at work. Math required for machine learning. I'm always making math related videos and they are all useful in machine learning. Okay, politics stuff. Okay, John didn't get notification. I don't know why. You missed a scary game. This one. So you have to find Slender Man here, kind of like a Where's Waldo, and when you find him, it's a game over. And you can get it from GitHub. It should be in a link somewhere in the description. So this one, it's not in the description, but it's in the chat now. I'll add it in the description at the end. And yeah. Yeah, floating head. Hello, Pesterenan. Yeah, there should be a jump scare. Check my other videos, the scary maze game from last year, this one. It had me recording, like shouting here and also making a scary face appear there. So you can check that one out. Unfortunately, I'm ending now. So all of you who are coming late, sorry. But I'm have to get home and close things up. I've never tried NeoVim. I'm not that hardcore. Yeah, glad you liked it. Yeah, Slender Man is the one getting somehow. we are stalking him. It's like when we get to find him, it's like aha. Maybe it's like that. I don't know. It's missing sound effects. I wanted to make some kind of sound effects for the steps and maybe also some kind of lateral movement, making it more interesting. But it is what it is, and it was more difficult than I thought it will be. But I'm happy with the end result. And you can take it from GitHub, and if you make updates to it, I might show them in a future video if it's something nice. So up to you. Be creative and have fun being scared during Halloween. I don't do PhD supervision anymore or research. I just do teaching in bachelor level nowadays. Okay, so thanks you all for watching and see you around. Probably there will be another live stream on the advanced drawing app at some point. Some point soon. I think that it's actually, I might have it already decided when it's going to be. 14th of November. So probably this is going to be the last live stream of the year. So if you want to see how that application has advanced meanwhile, check it out. Otherwise, more Halloween related videos. So the Scary Maze game, Talking Pumpkin, Theremin, Torch Effect, these things you can still look at now because it's Halloween time. And if you want to somehow, I guess I don't call it like that. Like this one, where you have to somehow not touch the borders. I think it was like that. That has the jump scare in it. And then the talking pumpkin, I guess that's not very scary, but let's see how that one looks like. Can't find it with pumpkin, but the link is there. Talking. No character. I think it had a general, yeah, this talking pumpkin there. And then the theremin. This one is kind of spooky. And this torch effect, I think this had a very generic name, like this one. So you can watch more stuff if you want. Otherwise, let me add here the GitHub link from this one as well. Yeah, so thanks for watching and see you guys. Oh, wait, somebody is there writing something. Free subscription. I don't know who teaches machine learning with JavaScript. I only teach it because I visualize it. I like visualizing it and I like implementing the things from scratch. So the thing is that when you are forced to kind of implement things from scratch because JavaScript has way fewer libraries for it, you kind of learn more about the inner workings of it. So it's also another reason why I made that series. And yeah, I can give away some more memberships because I think that there is another one possible here. So I have 5 more to give away this month. So take it as a Christmas present, early Christmas present. And then after this is over, I'm done. So yeah. Right. So I think that's done. Thanks for watching. See you